Now let's discuss about the control system model, which is very important part of in any computing system. This subsystem actually orchestrate the operation between ALU, memory, register file, those all three other major components in a computing system. So we already know about this system and studied about that. We know about ALU, how its input output look like. We know about the register file. We know about the memory on all the incoming signal and outgoing signal. And this control system sits and control these three components. Okay, this is the control unit. It has two very special register. One is called program counter, another is called the instruction register. So program counter, the purpose of the program counter is to store an address of the next instruction, so that when this system tries to execute the next instruction of the program, it knows where to get them. So it grabs it from the memory, some location, so during which control unit issues that address, 10-bit address to this memory system from the program counter, and make it a read operation. Of course, keep the reset operation ineffective, so that it does not wipe out the memory. So it takes care of that. And then next cycle, this memory returns back the instruction from the memory to the controller, and that instruction being stored in the instruction register. Okay, so this is like the instruction fetch cycle, we call it instruction fetch cycle, where it basically picks up the next instruction to be executed by the computing system, and that next instruction is pointed by the program counter, which stores the address of the next instruction in the memory. And then what happens is this. Let's say there is an addition operation, okay, requested as a next instruction. Okay, so control unit, it reviews that instruction stored in the instruction register and takes next course of action. Basically, let's say if it is an add operation between two operands, and maybe the two operands are stored, let's say, in the register file. So what it will do first go and access this register to fetch that two operand. It says the R1 and R2 address for those two operand register values, and it get back the value from the register file. Okay, that two operand value. So it sets the register file into the read mode, keeping of course the reset inactive there, and so on and so forth. So it gets the value from the register file with that register read operation. So this is a register access step, let's say. And then next what it will do, it will send these two value got from register file to operand value into the ALU, and also sets the operation code to the ALU based on what instruction have been given. It may be add, or maybe multiplication, or addition, or subtraction, something like that. So it knows what instruction has been requested and sets the operation accordingly to the ALU. So ALU then gives the result back. And then what happened with that result, it can either send it to the memory or register file, depending on what type of system we are discussing. But let's say this result from the ALU will be stored in the register file. So what control unit will do is basically sends that result from the ALU through this data inline into the register file, and also sets the right address into the register file, and set the register file operation mode to the write, means set the read signal to 0, write signal to 1, so that in that cycle this result is written back. Okay, so let's call it a write back cycle. Okay, so this is how it kind of control the operation and synchronize the operation between all those other three component. Okay, and throughout this semester, what we'll be focusing on a very specific type of design, which takes like a 5 cycle. Okay, we'll come to that in a moment. The other point is that this force system is basically your whole computing system. However, this control unit ALU register file, this system together builds a processor. That's what makes a processor. So if you open up a processor, any processor, okay, it will have these conceptual units there. There will be a control unit, there will be an ALU, one or more maybe depending on what processor you are talking of, and register file. Okay, so these are the very basic components of an processor, and these three systems together, what we call a processor system. Usually your memory stay out of the processor. Okay, main memory, at least the main memory system. There are more can be complicated configuration on the memory. Some part of the memory can be in a part of the processor. So we'll discuss that in this course in the latter part of the semester. But point is this: like if we open up a computing system box, we'll see two distinct components there. One component is a memory sitting on the motherboard. Another component is the processor sitting on the motherboard. So this processor, inside that processor, you will find at least these three type of components: register file, ALU, and control unit, and that's what the processor is. Now, this processor, the one we'll be discussing throughout this semester, is a very special type of processor, very simplistic, and it execute instructions or any user program through a constant amount of predefined cycles. Okay, let's study that. Okay, so upon power on the control unit, what will do? It will first reset the entire system. So it will issue the reset signal. It will wipe out the memory, main memory. It will wipe out the register file, and that becomes kind of a part of your when you turn on the computer. Okay. So once the reset is done, then it will start with the instruction fetch. As I explained earlier, it will send an address stored in the program counter. Now you can say that what is the value to start with? So that the very first instruction it fetch from the memory, the address of that very first instruction is fixed for each processor. If you look at the processor specification, like hardware specification, it tells about if you power on, give the first time the power, what that program counter value set to. Okay, it's different from different processor and definitely doesn't start from 0000. Okay, it is a predefined value. All right, so that's called a power on value of the program counter. So means when we power on or when we actually reset the whole system, every register file, every memory goes to its reset value, which is usually 0, but not for the program counter. Program counter, even for the reset, it will set to a predefined fixed value, and from where the very first instruction will be fetched. Once the instruction is fetched, then the next step is called instruction decode step, where control unit chop off this different part of this one instruction and try to understand what operation has been requested. Okay, so that is the instruction decode, and during that step as well, if needed, control unit can also initiate a register fetch cycle. So usually it is not really only a lone ID or instruction decode. It also associate with a register fetch or RF. Okay, So once this instruction decode register fetch is done, then an execution cycle happen where it sends and involves ALU to compute some result. Okay, and then next cycle is a memory access. Now this is a very one specific step, and not all the instruction is needed a memory access. Okay, so if a instruction is needed a memory access, means for the store the data or load the data from the memory, then only this step will involve the memory component and will send the instruction to the memory with the address and certain read or write request. It will be sent by the controller. So point is that not all instruction involve a memory access, but it may. Okay, some instruction definitely will involve a memory access, but nonetheless, whether it involve the memory access or not, processor will go into this step. Okay, at this phase or this step, if there is nothing to be done, processor won't take any action. It won't send any request to memory. Okay, if there is something to be done with the memory, then only processor will send the request to the memory. And then once this is done, then something called a write back, when the result, some result, either coming from the ALU or coming as a result of the memory read or something like that, it will go back and write back into the register file, and then it repeat things from the instruction fetch, which is fetch the next instruction, decode and register fetch, execute and crunch the numbers, then memory access if needed, and then write back, and then go back to the fetch, and this goes on forever from the turn on, okay, till you turn off. So everything goes off right there. So in this process, if you even think, and we'll assume that as well, each step is one clock cycle long, that means you need to complete one instruction. Let's say you in the like in your assembly program, if you given like an instruction like add R1, R2, R3, for example, it will take 5 clock cycles to actually complete executions of that instruction. Okay, so it will do the first fetch that instruction, decode register fetch, then execute. It will go into the memory access and then write back the result. So each assembly instruction or machine code is associated with the 5 cycle. Okay, so we'll be developing a 5 cycle processor like this, which follows exactly this step always. Okay, but not all the processor follows the same 5 cycle. It can be more, it can be less, it can be dynamically adjusted depending on the complexity of the processor, but they are outside of our scope of discussion. Okay, so that's your control system.